well, I'm not sure exactly what happened there, but all of a sudden Google decided they wanted me to log back in. So I'm not sure. I'm not sure what the glitch was there. Whatever, we'll roll with it. Also, I guess no one's here, so I need to figure out how I can get the link back out there. So give me a second. The other problem is it looks like YouTube has some new policies with the chat. So I kind of have a double-edged sword here where I can I have to select whether what my content is, if it's for kids or not. So if I do that, it disables the chat. But if I say it's not for kids, then you guys can't watch it. So looks like I'm gonna have to find another way to figure out how to get the chat going. So I'm trying to think of other options I would have here. So what I'll do is, I know to my phone I can get Google Classroom alerts, and I know that doesn't help everyone in different classes, but okay, the comments are rolling in here. So anyway, yeah. So what's nice is if you post in Google Classroom, I'll get an alert, and it'll at least tell me what your question is. So at least there's that way that we can exchange information. So like I said, my phone's got the Google Classroom app. So if you have questions along the way, I'll just look on there and it'll alert me, and we'll just make do with what we have. So, but I'm going to be going over the study guide tonight. That's kind of the main goal of today. So I'm going to go through each problem. And again, these problems are very similar to what's on your test. So it's very important that you feel confident going into tomorrow's test. So, we'll start with the first problem. And again, we're looking at the Cycle 7 expressions study guide. Okay, so if you don't have that in front of you, might be a little tougher, but for the first page. But the other pages have the expressions I can just write on my board here. So it looks like I got to zoom in a little bit. I'm pretty far away from my stuff. So again, I got a new tank, new setup. So we're gonna be messing with that a little bit today, making sure that everything looks the way it's supposed to. Sorry about my wobbly table. So we're working out the kinks here. So, all right. So the first problem says, there are 6 quarts of applesauce in a pan, and it says Mrs. Wiesner, who gets a shout out in this problem, looks like, fills containers with 1/8 of a quart. Okay, so we have 6 total quarts. Okay, so it's according to the problem, and again, I'm just kind of writing down details on the problem in case you don't have it in front of you. Okay, you have 6 total quarts, and then you're filling 1/8 of a quart, and that says you're pouring that from this container. So you have a container of 6 quarts, and you're pouring 1/8 from the container. And so it asks us to write an algebraic expression to represent the situation, and to use C to represent the number of containers, looks like. Okay. Yeah, okay. So in this case, let me see, you have 6 quarts of applesauce in a pan. Oh, it fills containers. Okay, so each container has 1/8 of a cup. Okay. Okay, I see. Bear with me tonight. I had a wrestling meet, so I'm a little tired from that whole ordeal. So if I'm a little off my game tonight, I apologize. So, so basically, the way to approach this problem, we're writing an algebraic expression that represents what's going on in this problem. And so here's what I'm seeing is that we start with 6 quarts. Okay, and for every container we fill, we're losing some of this total volume from the 6 quarts, okay? So we have 6 quarts, right? And then we have 1/8 of a quart per container that we're taking away each time. And that's how we arrive at this. We have 6 total quarts, okay? And every container we fill up, we're losing 1/8 of a quart to each container. So the number of containers is gonna tell us, or sorry, the number, what am I saying? Sorry. Oh, so basically what we're trying to find out is if I have 6 quarts of applesauce, how many containers can I fill up? Okay, so that's our independent variable there, is the C. Okay, how many containers can we get until we run out of quarts? Okay, so that's where this one came from. It's a little, I can see where there'd be a little confusion. But in this situation, we have to realize that we're starting with an amount, and little by little, we're chipping away at that amount. I got a big pot of applesauce, and I'm pouring it into a 1/8 of a quart containers. And so I'm trying to figure out how many containers can I fill till I run out. Okay. So now it says use the expression to determine how many cups of applesauce is left when you fill a certain amount. Okay, so the first problem says filling 2 containers and then filling 12. We want to figure out how much is left. Okay, so the first problem, we want to know when we fill 2. The second problem, when we fill 12. And we're going to use the same equation here. Okay, so what we're doing here is we're what we call evaluating the expression. Okay, so when we evaluate an expression, what we're doing is we're given a value, and we're going to plug the value in for the variable, and we're going to see what we get. So that's what we mean by evaluate the expression. Okay, so in this case, they're giving me a variable for C. They're asking, what does it mean, or what is it going to equal when we replace C with 2, and what's it going to equal when we replace C with 12? Okay, so we'll do both equations. Okay, and I'll do 1 over here, and I'll do 2 over here. Okay, so I'm going to take this equation, and I'm going to plug in the value they give me. So 6 minus 1/8 times 2. And again, when I'm putting things in parentheses like this, and just showing that I'm replacing the variable. I'm still going to multiply, but in this case, 2 is going to take the place of the variable. Okay, so the other problem is 6 minus 1/8 times 12. Okay, so now what we're going to do is we're just going to evaluate this expression, which means we're just going to solve it, and we're going to simplify it essentially until we just have one number left. Okay, so I'm going to do 2 times 1/8, which would be, if I have 1/8 and 1/8, I now have 2/8. Okay, so 6 minus 2/8, and we know that 2/8 is the same as 1/4. Okay, so really what we're doing is 6 minus 1/4. Okay, and that would leave us with 5 3/4. Okay, I know I kind of ran out of room there, but that should say 5 3/4. Okay, and again, all I'm doing here is multiplying, right? When I'm multiplying by a whole number and a fraction, I multiply the fraction by the whole number as if it's over 1. Okay, so that's where 2 times 1 is 2, 1 times 8 is 8. That's where that came from. Okay, so the next one, we're going to do the same exact thing. We're going to evaluate this expression, but now we're going to use 12 instead of 2. Okay, so and that's where I've plugged 12 into the same equation, or the same expression. Okay, and again, this isn't an equation, because an equation would mean that we have an equal sign and a value. Okay, and since we don't have either, we don't have an equation, we have an expression. So we can't solve the equation, we have to evaluate the expression, which is a little bit different. Okay, so in this case, they gave us 12. We're going to do 12 times 1, which is 12. And we're going to put it over 8. And we're subtracting this from 6. Okay, and if we were to reduce this down, okay, we would have 6 minus 12 divided by 8 would be 1 1/2, right? Oh, I'm wrong. Sorry, 3/4. Oh, wait. No, that's right. Yeah, sorry, 1 1/2. Okay, and 6 minus 1 1/2 is going to give us 4 1/2. Okay, so that's where these numbers come from. Okay, and I'm going to double check Google Classroom, see if there's any questions about that. And again, sorry that the chat is not working tonight. So let's see. Can I ask my questions on here? That's a great question. The answer is yes. That's the point. So yeah, so I mean, like I said, it'll alert me when I get a comment on Google Classroom. So, you know, if you got that was a great question. So feel free to ask more questions. Do you have something I can wipe this board with, by the way, Steph? What? This is my life. This is what I do when you're at work. Yeah, if you got a baby wipe, that'd be great. So thank you, Mrs. Coffee, for the assist. Look at that, baby wipes. Thank you. Don't judge me. This is my job. Anyway, so we're going to erase that. Okay, and again, if it's gone and you had questions, you can always go back, watch the stream again. Okay, it does save afterwards. Okay, so. All right. I'll be right back. All right. Don't tell Mason I'm borrowing it, the inside of his pants here. So, no, it's the inside. You know, see, like the outside looks just fine. That's what he gets for leaving them around. Okay. So next problem. I'll go ahead and read this problem to you, and then we'll talk about where the pieces of the equation come from, and then we'll evaluate the expression given the values that were given. I feel like I said given like 8 times there. The temperature at 5 a.m. in Alaska was negative 14 degrees Celsius. Okay. So we're negative 14 degrees, okay? And then it says the temperature is predicted to increase by 4 degrees every hour, okay? So what we're doing here is we're increasing, okay, by 4 degrees, okay? So we're adding 4 degrees every hour, and we just don't know how many hours that's going to be yet, right? Because that's what we're going to evaluate as well. What temperature would we be at if 5 hours had gone by? What if 24 hours had gone by and we were still trending in that same direction? Okay, so that's kind of the logic of where the equation comes from, because I'm starting at negative 14 degrees and my temperature is increasing by 4 degrees every hour. Okay, so then it says use your expression to determine the predicted temperature after 3 hours and 6 hours. Okay, so again, all we're going to do is we're going to replace h with a value. We're multiplying by h, so whatever value we plug in, we're going to multiply that value, and we're going to evaluate the expression until we have one number left. Okay, so I'm going to keep the 14. That's not getting messed with. I'm going to keep the 4, and I'm timesing it by 3 for the first problem. Okay, so and again, order of operations, remember, okay, parentheses, exponents, okay, these are parentheses, this right here, okay, and then we're going to do multiplication and division, right? That's a dot, that's a division sign, okay, and then addition and subtraction. Okay, so remember, order of operations, we have to evaluate things in the correct order, and if we can't do this order, then we have to find a way to work around that, which I'll get back to when we get to the other things we're going to go over in this live stream. Okay, so in this situation, all I'm going to do is do 4 times 3, which is 12, because order of operations says I have to multiply before I can add. Okay, so I have negative 14 plus 12, and we know from our prior units that that would bring us to a negative 2. Okay, and the problems ask for degrees, right? So degrees Celsius would be our label there. Okay, and you should know that from science class. All right, so now same expression, but we're going to plug in a different value for h. We're going to figure out what about 6 hours? What temperature will we be at after 6 hours? So all we're going to do, okay, is we're just going to redo the expression, but we're going to use a different value. We're going to use 6. Okay, so now I'm going to evaluate the expression by same deal, same order. 4 times 6 is 24. I'm adding this to a negative 24, or sorry, negative 14. Okay, and when we have a negative number, we're adding a positive number. The positive number here is bigger than the negative number, so that should pull us into the positive. Okay, another way you can look at this is 24 minus 14. We can rearrange it that way, because adding a negative is the same as subtracting a positive. Okay, and then we would see here that it's 10 degrees Celsius. Okay, so again, those first 2 problems, it's just a matter of slowing yourself down, know what you're looking for, and being able to, once you have the correct equation, then you're able to evaluate it. So one thing I will tell you is whatever equation you come up with, if you come up with an equation and it doesn't happen to be if you come up with an expression and it doesn't happen to be the right one, if you still evaluate it properly, you're going to get a majority of the points. Okay, you're only going to lose points on that first letter A there, because we didn't get the right expression. But again, if you're evaluating it correctly, then there's no reason that I can't give you some points on that. So, because that's the skill. One second, guys, hold on. Okay, so I'm gonna go ahead and erase this. I don't see any questions on it. So yeah, so we'll keep on trucking, I guess. Again, I'm really annoyed that there's no comments. We got a little spoiled by that, and I'll have to look into the policy and see what I'm able to do with that, if I'm able to still do that in the same way. So, new fish tank. What do you think? I still got to clean it though. It's still the glass is a little grimy. So, sorry, Mason. You'll never know. Okay, I heard an alert, so we'll see if we got a question here. Let's see. Here we go. It says, Mr. Coffey, the only thing I have been confused on is really how you get if it is subtracting or adding, then combining like terms like page. Okay, well, luckily page 2, that's where we're going to go right now. So we're going to talk about those things pretty in depth. Okay, so it looks like we're good on the other ones, but again, for these next problems, the key really is to make sure you're following the order of operations. Okay, and the tricky one is parentheses. Okay, if you have parentheses, if you can't evaluate what's in the parentheses, then we have to use distributive property. Okay, let's see, we got another question. Come on. Where'd it go? Okay, another question asks, I'm sure there's no more questions about the one we just did. So, why did I switch them? I switched them because I could. Just to show you that when I'm doing negative 14 plus 24, that's the same as 24 minus 14. Okay, I would get the same results. So I was just showing that, again, we talked about in mathematics, you've been taught since you were little that you cannot, there's certain things you're not able to do. But again, now we know the rules of mathematics. You've learned a lot more since your younger ages. You've learned that, yeah, you can subtract a bigger number from a small number, but then you go into the negative. And we talked about that concept and kind of how to, rearrange and bend and even break some of the rules of mathematics that you've been taught previously. So we talked about that pretty extensively in the last unit. So I'm going to go ahead and move on from that. And then again, if you still have that question, feel free to come see me. We can talk about it. I don't mind. All right. So the next page says evaluate each expression. Okay. So very similar to what we just did. And I'm going to put all 4 of these problems on the board. Okay. So I have 6g minus 11. And Mathia goes over these very extensively. Okay. So there's a lot of these in Mathia, and there's a lot of good practice there. So assuming for tomorrow's test that you have done your Mathia, it's fairly reasonable to say that you should do pretty well. And I wrote those way too close together. So we got 4c plus 2g, or minus 2g. Okay. And a plus 7 squared over c. Okay. So again, now what we're going to do is we're given, I'm going to change colors here. So we've been given some values for each of these variables. We've been told that g equals negative 7. We've been told that a equals 5 and c equals 1.5. Okay. So all I'm going to do is replace the variable that I have with the value that I'm given, and then we're going to evaluate the expression, basically reducing down until we have one number left. Okay. So, or one term, I should say. Okay. But in this case, we're given a value for the variable. So we will be left with just one number. Okay. So in this case, g equals negative 7, and I have a g here. So I'm going to take 6. I'm going to plug in that negative 7, and I'm multiplying by g. So I'm going to multiply by negative 7, and then I'm going to subtract by 11. Now, again, we go to our order of operations. I have no parentheses. I do have parentheses, but there's nothing going on inside there besides containing the negative. So though there are parentheses there, there's nothing really I can do with that right now. There's no exponents. There is multiplication because I'm multiplying 6 by this negative 7. That happens to be in parentheses. I know 6 times 7 is 42. I know positive times negative is negative. And I'm subtracting 11 from 42. Okay. And so if I have a negative number and I'm subtracting a positive, I'm going further into the negative. So I'm going to combine these terms and get a negative 53. Okay. So there's my answer for that one. Okay. Oh, yeah. That's a good reminder. Thank you. Okay. So a student just reminded me too. We talked about when we're multiplying, don't forget this little hint as well. Okay. That if you have positive, negative, negative, okay. We talked, and we showed this in class too, where you go to figure out what you're going to wind up with if you're not sure. And I know some of you are still a little shaky on multiplying and dividing by negatives. Okay. So if you are multiplying by a negative times a negative, you're going to wind up with a positive. Positive times negative is negative. Okay. Negative times positive is negative. Okay. So you can use that triangle to kind of guide your way around there. Okay. All right. So moving on. Okay. That one had a variable somewhere. Oh, A. Okay. So this one is negative 2.3a plus 4.6. So negative 2.3. Okay. And A has a value of 5. And we're adding this to 4.6. Okay. So again, order of operations, I have multiplication. Okay. So I'm going to do the multiplication first. A negative times a positive is a negative. 5 times 2 would be 10. Hold on. Let me see. 5 times 0.3 would be 1.5. And 2 times 5 would be 10. So 10 plus 1.5 is 11.5 plus 4.6. Okay. So now what I'm going to do, okay, is so this is negative, that's positive. So I have more on the negative side. That's going to win the tug of war match, as I say. Okay. So now it's just a matter of finding the difference between these two. Okay. And if I'm doing this correctly, let me think here. Let me see. Hold on. Should be, I think, 6.9. That's not right? No, it's not right. Is it? Yeah, that's right. I think. All right. Anyway, 6.9. My brain's not working. It's been a long day with wrestling and with school and stuff. So forgive me. But when you add and again, you can use a calculator on this test. Maybe that's what I should be doing. If you use a calculator, that'll lead you to the right answer too. So this is a test where we get to have calculators back. So take advantage of that. Make sure you have your calculator in class. I get a lot of people come in not having their calculator, which blows my mind. Okay. So now here I'm going to replace C with 1.5. And I'm subtracting this from 2 times whatever G is, which is -7. Okay, now what's cool is if I have 2 multiplication steps, I can do them both in the same step. Okay, so again, we have parentheses, but nothing going on inside of them, but just containing the number that we plugged in. Okay, so now no exponents, multiplication and division. Remember, these are the same step. Okay, these are separate steps, but multiplication and division, they're on the same level, and same with addition and subtraction. You can do them both at the same time. Okay, so 4 times 1.5 would give us 6 minus 2 times -7. Sorry, and again, ooh, here we go. This is a -2, right, times a -7. So that's going to bring this, that's 2 times 7 is 14. Negative times negative is positive. So our answer here is going to be 20, okay? So remember, if we're subtracting a positive, it's the same as adding a negative, which means I have to multiply by a -2. So -2 times -7 gives us that positive 14. And I know that that's thrown some people through a loop, so... and I got a question about this one. Why is this one still negative? Well, because negative times a positive 5 gives us a -11.5, and we're adding it to a 4.6, and so -11, I'll bring the negative sign closer. -11.5 is further in the negative than 4.6 is in the positive. So when we combine those terms, we're still going to be in the negative. Adding 4.6 isn't enough to bring 11.5 back to the positive. Okay. All right, last one for this portion. So we're going to plug in 5 for A. We're going to add it to 7. We're going to square it, and then we're going to divide by 1.5. So there's a lot going on here, okay? So step 1, I got to do what's in the parentheses. And in this case, I can do that. I could do 5 plus 7, which ends up being 12, okay? And bring everything with us, okay? So I'm just kind of going one step at a time here, okay? So now I have an exponent. I'm squaring 12, okay? I'm going to draw it this way. So 12 squared, so 12 times 12 is 144. And I can't write tonight, apparently. Okay, there we go. 144 divided by 1.5. Okay, so another way to look at this is 1.5 times some number got us 144. Okay, and if I did the math correctly, let me see. That's got to be, I think that's 96. Let me double check. Okay, but I'm going to use my calculator, of course, because I'm allowed a calculator on the test. 144 divided by 1.5 gives me 96. There you go. Okay. So again, if you're from here to here, if you need to use a calculator, that's okay. That's allowed on this test. Okay. So, all right. So again, if you need to watch this again, it'll be there. Okay. All right. So now we're going to start getting into using the properties involved with expressions. So I'm going to go ahead and erase this. It'll be there for you afterwards. Probably shouldn't have erased my little triangle there. That was helpful. Okay, I am going to leave the order of operations because I am going to refer to that as we continue on our magical journey here. Okay, so next order of business. It says use the distributive property. So we're on number 4 now. Use the distributive property to write an equivalent expression. Okay, so what we're going to do is we're going to take a problem and we're going to distribute to each term in order to write an equivalent expression, okay? And there's times where you want to distribute, but there's also times where you want to factor, which is going the other direction, okay? So in this case, the directions tell us what we need to do here. So we need to distribute. Okay, so what the distributive property means, okay, is that, I have 2 terms in here, okay? I'm going to combine them either by addition or subtraction according to this, and even some multiplication. I'm going to do a bunch of stuff in here. And I'm going to take all that and times it by -6, okay? The distributive property tells us that instead of doing that mathematically, what we can do is we can give the -6 to the 3x, and we can give the -6 to the -9, and we can, we can multiply each of those separately, and we would still get the same answer. Okay, so I'm going to use some real numbers here to give you an example of that. Okay, if I took 2 times 1 plus 3, Okay, we're going to do this twice. And again, this is why the distributive property works. And again, we should have learned this in, I think, 5th grade. Okay, but again, it might have been a while. So what I can do here is I can do 2 times 4, because 1 plus 3 is 4. If I multiply 2 times 4, I get 8. Okay, or what I can do is distribute the 2. I can do 2 times 1, which is 2, plus 2 times 3, which is 6, and then I also get 8. So both ways work. But again, in this situation, the directions are pretty clear that this is what we're supposed to do. So I just wanted to show you why the distributive property works. Okay, so I'm going to erase that. All right, and let's use the distributive property to deal with this problem here. Okay, so I'm going to do a -6. Okay, and here I want to point this out as well. And I talked about this with my class. My recommendation is, I know that this says -9, but I would start looking at that as a -9. Look at that whole term. That's a positive 3x, and that's a -6. Okay, so when we're distributing, we're giving a -6 to each part. And the reason that's important is we have to know what sign we're going to wind up with. Okay, so in this case, I have a -6 times a positive 3. That's a -18. Bring the x with you, right? So the x has to come with whenever we're multiplying. Okay, and then I have a -6 times a -9, which is going to be a positive 54. Okay, so that does change the sign to positive because I have a -6. I'm subtracting positive 9, which is the same as adding a negative. Okay, mathematically speaking. Okay, so again, that's why I say I want you to view this whole term as a negative term because we're taking it away. Okay, and again, that'll make sure that you end up with the correct sign when you evaluate these expressions. Okay, questions are rolling in. Let's see if I can navigate between everything. There we go. Okay. I'm seeing some, they're not questions, they're statements, so I'm not sure how to respond to some of these, but all right. Okay, so next one says we have a 14x minus 42, and we're dividing this all by 7. Okay, so another way to look at this, okay, same thing, we can distribute the 7 to each piece here. Because I'm dividing the whole thing after I work all this out, dividing it by 7, but I can also divide each part by 7. Okay, so you can look at this as 14x divided by 7 minus 42 divided by 7. Okay, 14 divided by 7 is 2x. We're subtracting 42 divided by 7, which is 6. Okay, and so now we've been able to reduce those terms down. And the last one, same concept. We have I'll write it in red. I've been trying to be consistent here. Oh, jeez. Okay, so I have a -36x plus 24 divided by -3. All right. So again, I would look at this as you're dividing both terms separately by -3. And again, make sure you bring the whole negative with you as well. So a -36 divided by a -3 would give me a positive 12. And that has an x, and that does not. I'm going to bring the x with me. Okay, I have a positive 14 divided by a -3. So my answer is going to be a negative, and 24 divided by 3 is going to be 8. So I'm going to use subtraction there. Okay, so that's how we use the distributive property, and that's what you'll be expected to do on your test tomorrow as well. Let me see. I see another comment rolling in here. So I think I'm starting to get the signs now. Booyah. All right. Hey, here we go. Forward progress. Okay. So now it says we're going to go the opposite direction. So now it says use an equivalent factoring. I think it says use an equivalent expression by factoring out the greatest common factor. Okay. So this one we talked about in my class was what greatest common factor is. Okay. So if you're in Mr. Coffey's class, this should look very familiar. If it does not, I'm a little confused. Okay. And that's okay. So it says to write an equivalent expression by factoring out the greatest common factor. Okay. So in this case, I'm going to do this one. I'm going to do this first one in a lot more detail so that you can understand the concept if you want to watch this a couple more times. And then the other two, I'm going to go through and use the concepts I'm teaching to talk about, what the purpose of it is, or sorry, what the when we factor out I'm just going to go over it. I'm just going to give you the answer there. Okay. So this first one, what we're doing is we want to find what's called the greatest common factor. Okay. So we look at everything we can multiply to get these numbers. Okay. So now looking at the m, remember the variable is attached to the 18. Okay. And we're going to follow the rules there and bring it with us. Okay. But in this situation, we have two numbers here that we're going to figure out what the greatest common factor are. Now, I'm writing it out, but you should be able to do this in your head, because in 3rd grade, you did rocket math where you memorize your multiplication facts. In 4th grade, I'm sure your 4th grade teacher, just like when I taught 4th grade, I told my students every day they should be practicing their multiplication facts, should know them as fast as their name. So looking at 18, you should know what its factors are. And if you don't, that's something that I would recommend practicing. Get an app on your phone or find a way to make that really ingrain it in your brain so that you're not spending time remembering how to multiply what by what equals 18. That stuff should just come to you right away, and then you can focus on the stuff we're learning in class, okay? So again, we're looking at 18 here. We want to figure out all the things we can multiply to get 18, okay? We always can use 1 and 18, okay? So we can always use the number and 1, okay? So 1 and 27, okay? And what you're going to do is you're going to work your way in, okay, and find factor pairs. So I know 1 is a factor. I know 2 is a factor because it's even, okay? And then I have to think 2 times what? Okay, well, I know that 2 times 9 is 18, so that's another factor is 9, okay? So now if 3 is a factor, which it is, what's 3 times what is 18? It's 6, okay? And I know when I'm done when I get to the middle, okay, because 3 times 6, and then I got to think, is 4 a factor? No. Is 5 a factor? No. So that's it, okay? That's how you know you're done, is when you get to the middle and there's no numbers in the middle. For 27, I know 2 is not a factor because it's not even. I know 3 is a factor because 3 times 9 is 27. 4 is not a factor. 5 is not a factor. 6 is not a factor. 7, well, 7, 14, 21, 28. Nope. Is 8? Nope, it's an even number, so 27 can't have a factor of 8. So I'm actually done here too. And again, I'm looking for the greatest common factor that they have. Okay, so they have some other common factors. I see they both have 3, and they both have 9. But the directions are telling me I need the greatest factor, the largest. So the largest one they have in common is 9. Okay, so what I'm going to do is I'm going to take 9 out of here. I'm going to divide these other 2 by 9, okay, because I'm putting the 9 out here, okay? And then 18m divided by 9 is 2m, and 27 divided by 9 is 3. It's positive, okay? So when I factor this out, okay, we're going in the other direction that we were with the distributive property. Okay, we're realizing that they have a common factor. We can pull that factor out. And there's a lot of reasons when you get older and you get into more complicated math why that is necessary and very helpful. Right now, we just have to understand the fact that it's a rule that we can do. And we have to make sure we understand the concept and be able to master the concept of being able to pull that factor out. Okay, so I know there's times you look at this and you're like, well, why would I ever do that? I promise you that's coming. You're just not ready for that yet in 7th grade math. But in 8th grade math, in high school especially, you'll use factoring a lot, okay? So it's a rule that we have to know works, okay? So again, both of these have a factor of 9. I can divide the 9 out, put it outside, and I can have a simpler expression, okay? I really want to show you why it works, but I'm going to refrain because I think we've already got enough on our plate right now. But long story short, if I wanted to, if I pulled that 9 out and that made it, all right, I'm done. I'm done. I need to stop doing that. Okay. So I'll go ahead and factor out the other 2 problems on the study guide, and then I'll look to see if there's any questions about any of those problems. So it looks like another question rolled in here. Let me see. Google Classroom is not very good about when I click on the alert taking me to it. If it helps you, say the annoying X that helps me. Yeah, so in my class, I talk about the annoying X that follows you everywhere that just won't leave you alone. Doesn't get the hint that you broke up. Okay, so, it's done, right? Quit following me around, but, the annoying X just follows you everywhere. So in this case, it's an M. The M follows you everywhere, I guess. I don't know. Anyway, so let's talk about B. Okay, so we have 12R. So this is the next problem. Minus 4. Okay, and again, I look at 4, and I ask myself, 4 is the smaller number here. Can 4 go into 12 evenly? And yes, it can. Okay, I know that 4 goes into 12 3 times. So I'm going to divide both these by 4. I'm going to pull a 4 out of here. Okay, so now 12 divided by 4 is going to leave me 3. Bring the awkward R, I guess. Okay, and I have a negative 4 divided by a positive 4. It's going to leave me with a negative 1. Okay, also known as a minus 1 in this situation. So that's what this one looks like factored out. And then the last one, letter C, is a negative 16, I think, y plus, I gotta put this in a better spot so I can see it and stop turning my head all the way around. Oh my God, that's way better. Why didn't I do that earlier? Okay, anyway, a negative 16y plus 4w, okay? Now here's the deal. They both have a variable, but they're different variables, okay? So if they're different variables, I can't detach them or combine them. And again, these numbers in front, don't forget the numbers in front are what we call a coefficient, okay? So I can't remove any of these from the coefficient, and I can't combine these, so I have to deal with them separately still, okay? So I have a negative 16 and a positive 4. They both have, I'm going to show you two different ways to do this. That might make you mad, but that's too bad. You have to know that there's two ways to do this. Whenever I have a negative on the lead term, I usually like to pull that out of there, okay? So I see that 4 can go into 16, so that's where I'm going to go with the 4. I'm going to take the 4 out of there, okay? So I can take a positive 4 out, and that leaves me, if I divide both of these by 4, negative 16 divided by positive 4 is negative 4. Bring the y. Okay, and then a positive 4w divided by 4. 4 divided by 4 is 1. 1 times w is w, so I can just leave this as a w. Okay, the other thing you can do, I like to do this when I can. If I can, I like to pull the negative term out. So in this case, you can actually pull out a negative 4, and the results will be similar. I just have to be careful with my signs. If I pull out a negative 4, I have to realize that I'm dividing both of these by negative 4. So negative 16 divided by negative 4 is a positive 4y. Okay, and a positive 4w divided by a negative 4 would leave me with a negative 1w, and 1 times w is w, so I do minus. So you can see, if I pull the positive out, the signs stay the same. If I pull the negative out, then I have to switch the signs. Okay, so that's really, you could do either one on a test and you would still get full credit because both of them are correct. It's just, again, sometimes, as you'll see, the further you get in your math career, sometimes it makes sense to pull the negative out. Sometimes it makes sense to pull the positive out. Right now, you just need to know that you could do either one, and they would both be correct. Okay, so whichever one you did, totally cool. And I mean, we could do it with this one too. I could pull out a negative 4, okay, and I would just have a 12 divided by a negative 4 would be a negative 3r. Negative 4 divided by negative 4 would be a positive 1. Okay, so both of these would be correct, just the same way that these two are both correct. Okay, and again, that goes back to the last unit. So these are things that we have to make sure we're retaining and remembering. Okay, fair enough. Okay, so let's see. Next order of business. The next 4 say write an equivalent expression by combining like terms. Okay, so this seemed to be the one that some people had some questions about, or at least want some review on. So I'm happy to review on that. But again, make sure all the skills we just talked about you're bringing with you so that you know how to apply them in situations like this, because it's going to help you understand the problem better. Okay. Sorry, Mason. Okay. So what A says, okay, and I'll number. So we have A, we have B, we have C, we have D. Okay, so I'll try to get all these on the board at one time. So the first one says that we have 11xy, okay? So this one has two variables, and we're taking away 13xy. Okay, so they both have the same variable expression. Okay, they both have an xy attached to them. So if they both have the same variable expression, I can do addition and subtraction. Remember, with addition and subtraction, I can only add and subtract terms that have the same variable expression, not just the same variable. Okay, so what I mean by that is, even though this is x, okay, I cannot add this to x squared. Okay, so they're both the same variable, but they're two different variable expressions. One is just x, okay, but the other one is x times x. That's what x squared means. Okay, so these are two different variable expressions, so I can't just combine them. Okay, so in this case, even though there's two variables, they both have the same variables, and we're multiplying both of them. So in this case, they have the same variable expression, so we can combine them. And a positive 11 minus a minus 13 is going to give you a negative 2xy. Okay, so that one, not too hard. Give me 1 second. Sorry. Give me 1 second. Okay, sorry about that. Okay, so the next one says that I have. Oh, geez. Okay. The next one says I have 17p minus 6p plus 9r. Okay, so the only two expressions, or the only two terms that have the same variable expression are 17p and 6p. Okay, so that means that I can combine these, but this has an r, so they have different variables, so I cannot add anything with an r to anything that has a p. Okay, or I mean, I can at least simplify it. Okay, but this I can do. I can do 17 minus 6, which is 11, and I keep the same variable, and I add this to 9r, and that's really all there is to do there. Okay. So then the next one says I have 4a minus, and there's a lot going on here, so make sure we're paying attention to this one. 3, 6a minus 5. Okay, so this one is a little more complicated. I'm going to draw a line here so it's not confusing. Okay, and this one we have to refer to our order of operations. Okay, so order of operations says I have to do parentheses first. Okay, but I can't do what's in the parentheses. Okay, so if I can't do what's in the parentheses, I have to look for a way to get rid of the parentheses while preserving everything that's in the equation. Okay, so, or in the expression, I should say. I keep saying equation, it's an expression because there's no equal sign. Okay, so I can't do 6a minus 5 because there's no a on that 5. I cannot combine them because they're not like terms. They don't have the same variable expression. Okay, but there is a negative 3 out here, and notice I said negative 3. Okay, I'm going to bring the sign with me here. Okay, and what I can do is I can distribute that negative 3 to each term, and then that makes the parentheses go away. Okay, so I have 4a. Okay, and now I have to look at what's happening here. I have a negative 3 times a positive 6a. Okay, negative times positive is negative, so we're going to keep that subtraction sign. 3 times 6 is 18. Okay, there's a variable a that comes with. Now I have to do a negative 3 times a negative 5. Okay, and negative 3 times negative 5 is going to be a positive 15. Okay, so now I can look at what I have here. These two have a's. Okay, so these two I can combine. 15 doesn't have an a. I can't combine it with the other two. So whatever happens here, I'm still going to have a plus 15 here. Okay, so I have a 4a minus 18a. Okay, now 4 minus 18, that's going. We're gonna go into the negative there because I'm taking away more than I have. Okay, if I had $4 and I spent 18, I would have a balance of, well, I'd have negative $14. Okay, and we're going to bring the a with. They both have that. And I'm going to bring down the plus 15. So I'm going to be done here with a negative 14a plus 15. Okay, hope that makes sense. Okay, I'm going to move D to here. Okay, so the last one, oh my gosh, same deal. There's a lot going on here. Okay, and again, we've done a lot of practice problems like this in my class for a warm-up. Okay, so 5 times 4c plus 3 minus 7. I'm going to run out of room here. Hold on. So I'm going to have to erase letter C there. Sorry, guys. Okay. So let's try this again. Take it from the top. Okay. So I have 5 times 4c plus 3. I'm subtracting 7, 2c plus 3. Okay, and then I'm adding 4c. Okay, so we've got a lot of c's here that we can use, and we can combine like terms. But again, if we can't do what's in the parentheses, okay, then we have to distribute to get rid of the parentheses so that we can then multiply. We can't move on to these steps until we've dealt with these. Okay, so in this case, I can distribute. Oh, geez. Remember, with multiplication, you can do that in the same step. Okay, so I can distribute once. I can actually distribute twice, all in the same step, and bring that all down together. I have a fuzzy thing in my hand. It's weird. Okay, anyway, so I can multiply each part in this parentheses by 5. I can multiply each part in these parentheses by negative 7 because I'm subtracting it. So that makes that I'm removing it, so that's similar to being negative. Okay, so keep in mind that that subtraction sign is going to come with us. Okay, so 5 times 4c is 20c. Just making sure I don't know if you can see that. There we go. Okay, 5 times positive 3 is positive 15. Negative 7 times positive 2 c is negative 14c. Negative 7 times positive 3 is negative 21. Okay, and then we still bring down this for c. Okay, so now what we're going to do is we're going to combine all the terms that have one single c. Okay, and there they are. And we're going to combine all the terms that don't have a variable expression. Okay, so I could rewrite this. Okay, if I make order, or so one of the properties of addition is the commutative property. When I'm adding things, I can change the order. So if I'm adding a negative instead of subtracting, okay, I can move those things around to put them next to each other. Okay, so I have a 20. I need to stop doing that. I have 20c. I'm adding to that a negative 14c, and I'm adding a positive 4c. Okay, and then I have a positive 15, and I'm adding a negative 21. All right, so now they're all next to each other. Okay, I just have to make sure I'm keeping my positives and negatives straight here. Okay, so 20c, adding a negative 14c, same as subtracting a positive 14c. That's going to reduce down to 6c plus 4c, which would be 10c. 15 plus a negative 21 is going to be a negative 6, which would be the same as subtracting a positive 6. So we would end up with 10c minus 6 if I did everything correctly. Okay, and I don't see anything in the classroom, so it seems like we're doing okay. That's not for me. Okay, all right. So we're on the last page, we're home stretch. Okay, so the next problem asks us, okay, let's get rid of that. And again, I'm kind of pressing on, but I also see that we're already 47 minutes in. I started late. I want to make sure everyone's getting to bed in the next 5 minutes here, or at least has the option, because, you know, you're busy kids. So I don't want to take up too much of your time. There we go. All right. So the next one says, determine that the following expressions are equivalent by evaluating for x equals 5 or by the distributive property. Explain your reasoning, okay? So you got a couple options here, okay? You could do, this is the way I would recommend, because again, if you feel pretty confident about the distributive property, okay, here are the two expressions, 1 7x plus 3 7ths. Okay, so what I could do is I could distribute this 1/7 to each piece here, and I could see if I get this expression. Okay, so to me, I feel like that's easier, because if I distribute and I get the same thing, well, then I could say, well, you know, because of the distributive property, I know that 1/7 times x is 1/7 x, and I know 1/7 times 3, which is 3 over 1. 3 times 1 is 3. Oh, sorry. And everything's positive, so I know I'm going to add. So 3 times 1 is 3. 1 times 7 is 7. So if I can say that these two expressions are equal through the distributive property, that certainly is a lot easier. Another way that you could do that is by evaluating. You could plug in x for either value like we did earlier. You could plug in 5 for x and then multiply it out, and if you get the same answer, then you know you got it correct too. Okay. So the next problem says, and there's 2 more problems left. So I will do my best with those. I'm probably only going to get through 1 more actually, and letter B I'll go over before class, before the test starts, to kind of prime our brain for the test. So the next one says, which expression is equivalent to, oh man, let's see, 2. Okay, so we're trying to figure out an expression that is equivalent to 3x plus 2 minus 6x plus 5. Okay, so right away I see that I have parentheses here. So my recommendation is let's distribute. Let's just distribute that right off the bat and see if anything in our choices is going to give us the answer we're looking for. Okay, but again, negatives here are key. Knowing which numbers are negative and positive based on where we have subtraction signs. Okay, so I have a positive 3. This whole thing's positive. Okay, this whole thing is positive except for the 6. This 6, we're subtracting everything over here. So this is a negative 6. So I have to be aware of that. I'm not distributing a positive 6. It's a negative 6. Okay, so I have 3 times x, which is 3x. 3 times 2, which is positive 6. Negative 6 times x is a negative 6x. And a negative 6 times a positive 5 is a negative 30. Okay, so now I'm going to combine the like terms here. Okay, So 3x minus 6x would be a negative 3x. 6 minus 30 would be a negative 24. Okay. And so right there, I can see that that's one of the choices, negative 3x minus 24. Okay. And again, there's some choices here, negative 3x plus 24. That's not equivalent. That's a different expression. 9x plus 24, that would be if you made the mistake of adding these two and subtracting them. And then the other one has 9x. So again, that goes back to that mistake. So again, we just have to make sure that we're using the right signs in order to get the correct answer. So unfortunately, my time is up for the evening. But on the plus side, you can pause this. You can watch it again. You can watch the parts that you need for tomorrow's test. Again, usually we like to try to get these out like 2 days before. So if any questions are left over after the stream, you can get them answered the next day. But with the holiday weekend, we just couldn't do that. So I appreciate you being flexible about that and understanding that. But again, just keep it in mind too, we take, the other teachers and we take time out of our nights to do this for you guys. So I saw about 20 people on here. So for the 20 people that were on here, hopefully you found it useful and hopefully it really helps you out in your test. And I'm hoping that the other people that didn't get to watch it live get the chance to watch it at least afterwards in order to get some of their leftover questions answered. So sorry about the chat. I'm going to look into what needs to be done about that. Sorry about the weird start. Again, I had to log back in. It was really weird. So overall, I think we've gone over everything we need to. So if you felt good about the study guide, then you should be going into tomorrow feeling very good. If you didn't get something on the study guide, again, my recommendation is go back to the part in the live stream, watch it over and over, try the problem over and over, try problems like it, make up your own problems and give them a shot. Those are all things that are going to help you prepare for tomorrow. And if you have questions in homeroom, come find me in homeroom before the day begins. So, all right, you guys have a good night. Thanks for tuning in, and I'll see you next time.